First, one more addition to the previous video about set theory. So in case that the elements of the set are no numbers, are strings, letters, so we need to use this notation. I mean, we need to put the quotations here. If we just put A, B as elements, will not work. So for the cases that are no numbers, let's just add the quotations there. After that, we can just work as before. If we want to display the elements, we can just put set A, run it, and there is the set of the elements A, B, so we can put more elements here. Let me put add the element C, run again. So this is the set of these three elements now. And we can also do all the operations that we have seen before. Let's add it here, power set, which will be another alternative way to calculate the subsets that we saw before. Let's run it. So here we have the subsets when the elements are not just numbers. Okay, so that's about set theory. Let's start now with some of the notions that we see in terms of counting. So first we can calculate in Sage just the factorial of a number. So in order to calculate, for instance, the factorial of 3, we are going just to write factorial between parentheses the number. And so here we get that the factorial of 3 is 6. Something that we could do by hand, right? Because this is just 3 times 2. But we can also calculate factorials that would be very hard to do by hand. For instance, the factorial of 30. Let's run it, and this is the result of the factorial of 30. So we can calculate also the combinations, these numbers that we call combinations of n taken k at the time. Well, the notations for these ones are going to be, no, this one is going to be binomial. So remember that the combinations are also the binomial coefficients, that's why this notation. So here binomial 5, 2 is going to mean the combinations of 5 elements taken 2 at a time. And then we run and we obtain that this is 10, something that we could have done also by hand. But let me copy and paste again here, and let's do sorry, I'm copying the wrong thing. So let me copy this, paste, and instead of 5, 2, let me do a combinations of 30 elements taken 15 at the time. Let's run it, and we have that the total number of combinations are this number here. So this is a way then to calculate combinations in Sage. And one more thing, we can also get an actual list of all the possible permutations. So for instance, if we have permutations of 5 elements and we write that list, Sage is going to list the actual permutations. Let's run it. So these are all the possible ways that we can permutate 5 elements. So one way will be to put them just as they are, 1, 2, 3, 4, 5. But then we can write it 1, 2, 3, 5, 4. And then these are all the possible ways to permutate 5 elements. We can try it with a smaller number. Let's copy and paste. And instead of 5 elements, let's say 3 elements. What are all the possible orders? Well, here we see explicitly there are not that many, how many ways we can order differently these 3 numbers.